NASA's Astrophoto Challenge lets you make your own space image using real astronomy data, this time featuring incredible views of interacting galaxies. But before you get started, let's find out more about what we're seeing in these remarkable images. When you look up at the sky on a dark night, you can see countless stars, and every one of them is part of the hundreds of billions of stars in the Milky Way, our home galaxy. But if you take a telescope and peer between and beyond those stars, you will see tiny glowing balls and swirling disks. These are other galaxies, far beyond our Milky Way. Each of them is a collection of stars, gas, and dust pulled together by gravity. Usually we find galaxies in groups, and when they're close together, sometimes we can see them interacting with one another.
Interacting galaxies are galaxies that are close enough to feel each other's gravitational pull. So gravity pulls on each galaxy's stars, gas, and dust, causing their visible shapes to change. And then depending on how strong this pull is, it can stretch galaxies out, compress gas to form new stars, or even tear them apart.
So rather than galaxies living in complete isolation, interactions can have a profound effect on the structure and future evolution of the galaxy.
While interacting galaxies can get twisted and stretched into countless varieties, there are some that take on a ring-like shape.
There is a special kind of galaxy which we call collisional ring galaxies, which we believe are formed in a rather unique way, in which you have a rotating Milky Way type galaxy and a small spheroidal galaxy falls down through the center of the larger rotating galaxy, driving a ring out through the disk.
And so the same process happens when you drop a pebble in water, for example. So the water that was there moves outward and forms this nearly perfect ring. And so these galaxies are really rare because the ring doesn't last forever, maybe a few 100 million years or so, which sounds like a long time, but it really isn't. It's just 1% of the time that the universe has been around. So finding them is actually pretty cool and really rare. Ring galaxies, they're already very rare, but the Cartwheel is even more interesting both visually and science-wise, because if you look at it, it's basically a textbook example of what happens after a major collision.
It has an outer ring, which, like as in the case of a cartwheel, would be the outer part of the wheel, and it has an inner sort of hub, which is actually composed of at least one or possibly two rings.
Then you have these faint spokes of gas and dust that are connecting both the inner and the outer ring. And then you see these two nearby galaxies, one of which looks like it could have been the galaxy that pushed through it in the first place.
Each of the Cartwheel Galaxy datasets you can use comes from a different part of the spectrum, and each tells us a different part of its story, as revealed by a NASA telescope.
So an image of the Cartwheel in visible light shows very much the stars in the galaxy, in particular the extremely bright and very blue stars in the outer ring, and the reddish glow from the inner ring and the very faint spokes.
Infrared observations help us pierce through the dust and reveal the warm gas in the rings, particularly in the outer ring where we see a lot of very intense star formation occurring.
If you look at the Cartwheel in X-rays, you see a lot of very bright points, and it's even hard to tell that they're forming part of the segment of the ring. We call them ultra-luminous X-ray sources. But it's very rare to see so many of them in one galaxy. In fact, the Cartwheel is almost unique in having so many.
This UV image is highlighting the youngest and hottest stars that are concentrated in the outer ring. So these stars were directly formed from the gas compressing during the collision. So you have this burst of young, hot star formation. My favorite thing about the Cartwheel Galaxy is that such a major collision, it may have completely reshaped the galaxy, but it also allowed for so many new stars to form that simply wouldn't have formed without it. The galaxy, it took this very dramatic event, and it turned it into something very new and beautiful, i.e. the new star formation that we see. So I think it's like very oddly inspiring, a story of resilience, because something can crash straight through you and disrupt everything, and yet you can still pick up the pieces and rebuild, which is exactly what the Cartwheel did.
Galaxy interactions aren't limited to remote parts of the universe. Close to home, our neighbor Andromeda Galaxy shows signs of having interacted with one of its own galactic satellites.
So the Andromeda Galaxy is the Milky Way's nearest large spiral galaxy, and it's about 2.5 million light years away. So it's really almost in our backyard compared with, for example, the Cartwheel. And one very obvious difference between the Milky Way and Andromeda is that Andromeda does not have obvious strong spiral structure. It's dominated by an inner bright core and a faint outer disk. So one of the things you'll notice about the visible image is that in addition to the bright core and the overall disk, you also see faint dark features, almost like a dark ring, where we believe there's dust that's absorbing some of the visible light.
Here we have a short infrared wavelength image of Andromeda. And so here we are seeing the starlight from the older stars in Andromeda. You can also see the companions again. So you can see M110 to the upper right, and you can also see M32 just under the center. The long infrared wavelengths that we're seeing right here in this image is piercing through the very dusty clouds and allowing us to see the actual inner structure of Andromeda's disk. And when you look at it, it doesn't look like continuous spiral arms like you would expect for a regular spiral galaxy. Instead, we can see that the matter is organized into these very distinct rings, kind of like the Cartwheel Galaxy.
So what I love about Andromeda, this large nearby companion galaxy, is that you can see it very clearly with the naked eye on a dark night. You're only really seeing the very central part of Andromeda. But what's amazing about it is that it's heading towards us at about 300 kilometers per second, which is about 670,000 miles per hour. At its present rate, if it's falling directly towards us, and most of the models think that it more or less is, it's going to collide with the Milky Way in about 2.5 billion years from now. Now that seems like a long time away, but imagine that the Earth is only 4.5 billion years old.
A lot of people think it's going to be very violent and it's going to hurt all the stars and stuff like that, but actually the stars don't experience too much when galaxies are colliding. They just kind of get drifted around a little bit, and it's we wouldn't really experience too much. It wouldn't be a super violent process like a lot of people think it would be, because there's a lot of space in between stars, and so they're not going to be colliding with one another.
The Milky Way will cease to exist as a band across the sky. All the stars will be scattered around. We'll end up merging with the Andromeda. It's a very exciting and dramatic thought, but far into the future.
Whether you choose to make an image of the Cartwheel or Andromeda Galaxy, you'll have a snapshot of a moment in cosmic time, showing how their appearances have been altered by their neighbors.
Understanding merging and colliding galaxies and the way they evolve over time is sort of central to the human quest of answering, why are we here and where did we come from?
Just like people, galaxies grow and evolve through their interactions with others. And so this teaches us not only about the incredible forces of gravity, but also about how change, even when it's disruptive, like in the case of the Cartwheel Galaxy, can lead to growth and something entirely new.
There are countless ways to mix and match these data sets, and we encourage you to submit your creations to the Astrophoto Challenge website. Your work might even be featured as a standout entry.
Try NASA's Astrophoto Challenge yourself.
We want to see the pictures that you've made.
Tell us about the colors you've chosen.
Share your images with us and tell us about your creative decisions.
Were your choices scientific, artistic, or both?